Welcome back to another episode of a podcast written by a software engineer. I'm your host, Perry, and boy, do I have a guest for you today. I'm with Kevin. Kevin, how are you?
Great. I'm super excited to be here. I know we've been talking about this for, a month or two already. And so, it's super great to be here finally.
Yeah, amazing. Thanks for being on the show, actually, because we talk about this all the time because I definitely never have the opportunity to talk to people that are so involved in machine learning, AI, and when you hear people say these kind of words, like everybody wants to know a bit more about it, and this is exactly me trying to get more out of it. So thanks again for being on the show.
Yeah, super happy to jump right into these topics.
Cool stuff. So the people who read the title, they know slightly what we're gonna get into, but Kevin, what do you do nowadays? And I think more importantly, how do you know me?
Right, so currently I'm at Notable Healthcare as a machine learning engineer. Started here towards the end of 2019, so I've been here about 3-4 months. And Perry, my good buddy, he sits right next to me, so we get to see each other and poke fun at each other every day.
And managed to convince you to get on this show so that we could talk even more about the crazy stuff we do every day.
Yeah.
But that's always, I feel this is more like a random coincidence because I even before meeting you, I've always wanted to have at least one data or ML engineer on the show. And even today, I don't even know what's the difference between a data engineer and a ML engineer, or even like a data scientist versus a data engineer.
Yes.
So what is that? That's 4 different combinations or something?
Yeah, the names and titles keep evolving throughout, probably the past 10 years. Data science, I think, really started, in the early 2010s.
Okay.
Before then, I think people doing this is either like a data analyst or a statistician. And then data science becomes kind of more, trendy in the mid 2010s when you have, big data technologies and a lot more machine learning and experimentation methods that became available. So there's data science. Machine learning is actually even newer than that. I think it becomes more trendy in the past 3 to 4 years as deep learning methods and some of the newer AI techniques become more and more popular.
Oh my God! I'm more than excited to get into that.
Yeah.
I think actually, what would you consider yourself? Would you consider yourself let me get this right, data scientist or data engineer or ML scientist or ML engineer?
I think the work currently at Notable does most resemble a machine learning engineer. If you think about a data scientist, I think more traditionally it's more based on data analytics. So that's the first level, and more about running A/B testing. If you have different websites designs that you want to test on your users, you would run an experiment to a design of the experiment to tease out which method works better. So that's typically what data scientists do. Machine learning engineer is really more about building software applications to do prediction. So we care more about the predictive outcomes than what decisions may be better for executives.
Or whatever use case or the actual business model that we're looking at the end. But also, my original question was it's slightly flawed just because, they're not mutually exclusive, you know what I mean? You could be a bit of everything, and then, it does make sense that nowadays, you might consider that your work is more geared towards, being an ML engineer, but there's definitely instances where you've got to have to put your data analyst hat on and just think at all that stuff. So
it's all part of the toolbox.
I wish I got into that. I'm just a regular software engineer compared to all of it. So I think what people would be interested in is, how did this all start? As in, at what point did you become a data analyst or a ML engineer or all that? And I think to kind of figure this out, a lot of times the way I do it is that we just trace back a bit, trace back at see if there's anything prior in your life that kind of made you go toward that. So I think something that's interesting is where are you from originally, and where have you lived in the past couple of years, just to have a bit of context.
Yeah. So I grew up, I was born in Taiwan. I was in Taiwan until I was 11. And so kind of my formative years were spent in Taiwan. And, at least I got to learn a bit of Chinese and could, converse well enough in Chinese. And then my family decided to move to New Zealand for junior high and high school. So that's kind of where I did that period of my time. Afterwards, I went to Northwestern in the U.S. for my undergrad. So that's kind of the journey in those early years.
That's so cool because I think what is quite relatable is that you have these families from like these Asian cities, Asian countries, and when they want to immigrate out of it, I think the top three options, like I don't know if it's a stereotype, but you have like Canada, and I think Australia's another big one, and like in third place is like New Zealand, and US is like kind of in that mosh or whatever. So it's so fun to see somebody because I know people that have their original roots like back in Hong Kong or Taiwan or like in these Asian cities, and my family immigrated to Canada, so we're one of them. We knew other people that immigrated to Australia, and some other people went to US, but I've never met any Asian family that like immigrated to New Zealand. So like that's why I think it's already a cool point. You don't have the English New Zealand accent though. Was that intentional or was that?
Yeah, I think personally I don't know. I don't have a really good way to keep an accent. I tend to just adapt to whatever is happening around me. I certainly wish I had some New Zealand accent now, but I've been in the U.S. I think close to 15 years, and it's gotten the best of me.
Yeah, I mean, after 15 years, I feel like anybody would end up losing it or changing it at that point. I mean, for me, it's the same battle. When I moved to the UK, it was always like the first maybe year or two. I'm like, I'm gonna keep my Canadian accent. I'm gonna keep it forever. And like by the time I moved to the US, I keep on saying so many random words. Like, what was it earlier today? It said like, oh yeah, they chucked it, which means that they threw it away. And then people were like, what are you talking about? I'm like, oh, gotta re-explain everything from scratch now. So, hey, at least we got a bit more common because New Zealand sounds a little bit more like,
I think it's a mix between British accent and the US.
And a bit of Australian.
It's very close to Australian.
I could confidently say that the first time I moved to the UK, obviously didn't understand anybody. So Australian, New Zealand, English, Welsh, Scottish, they all sounded the same to me. That's very offensive, but as somebody completely new there, that's basically what it was. But then, like I think by the time I'm left the UK, I'm quite confident to say I could distinguish like somebody that sounds more New Zealand or somebody that sounds more Australian. And is it good for anything? I don't think so. But I mean, that's way off the point of what we're doing today. But yeah, so I think a lot of things that usually happens is, so you spent a good chunk of your high school years in New Zealand, and most of the time towards the end of high school, that's where you kind of choose like your topics and everything. Were you in kind of the same mindset of always going into sciences, and that kind of led to, I guess, what you're doing today, or was that just a special case back then?
Yeah, I think in high school, math and science always just somehow appealed to me. Actually, since I was pretty small, it may have something to do with like my parents just had a bunch of science books and magazines laying around at home, and I just tend to pick them up over time. But I think a really formative experience I had in high school was, I think maybe it was junior or senior year. I had two extremely motivating and inspiring physics teachers. One of them was very animated, and he can make everything just sound like really exciting. The other physics teacher is very thorough, very detailed, and you can really understand how he approaches problems in a very thoughtful way. And so that had a big impact on me. I eventually chose to go into electrical engineering for college, mostly due to at that time, there was a science kind of project competition in New Zealand. It's called the CREST, and there's two levels. One is silver, one is gold. And our class, so the physics teacher decided to sign everybody up to do this silver CREST project. And so I partnered up with a friend of mine, and we had this wild idea of building our own maglev train. And so we, did our own research. We ordered a bunch of like huge magnets online. We looked up like electronic circuits on how to build induction motors to like drive this little train forward. So that was an experience that told me how exciting is like building, physical electronics and physical objects. So since then, I was like, electrical engineering is like just so cool.
Yeah, because I mean, like the it's very rewarding. You don't have to wait. The comparison is nowadays when you do something, it's like you gotta wait till it compiles, you gotta wait till like some result happens later on down the line. But like if you look at back then how simple it was something that you built and like it works and all that. I'm actually quite interested with what you just mentioned with Crest. Actually, is that like a national thing that they had available in New Zealand?
It's I think it is national. I think it's organized by the Royal Society of New Zealand.
Okay.
It's across high schools. Students can form teams and participate, and you get an award at the end.
That's really great. Does everybody get an award, or only the
There
people?
are judges that come by. So you at the end of the project, you do a demo of your thing. When they're on site, and you either get the award or not.
That's really great because it's really encouraging. And as you were mentioning, so they signed everybody up, so everybody really got the chance to do it, willing or not. But I think at the end of the day, I feel like these kind of people or these kind of programs that like pushes you to do something. Sometimes like there's always the kids that don't want to do it, but then they end up finding out something that they're like, oh, I can build like a speaker or something out of like coils and stuff. I did that during high school. Not intentionally. It really just impacts them. It really just like lets them understand what's cool, what's not cool at the end. So, context-wise, how old was it? Was it just anybody in high school? So from whatever, like age 12 to 17, or is it?
I think it's usually between 16 and 18.
Okay. Which is
junior and senior year.
Yeah, which is quite an age to get impacted, because as you were saying, like stuff like this like kind of help you make the decision for the next bit of your life, I guess, at that point. So that's actually pretty cool, because you said after high school you studied in the US, so that is a big jump. That's a big
It was. I remember when I was trying to apply to the US, I literally couldn't even find information on how to do it.
Bring us into the mindset of like what were you, like 17, like barely even, and like what was the mindset of back then of like there was a drive of going out into the world, you know what I mean? There was a drive there. So what did you do? What kind of option you saw, and like how did that go?
Yeah, I think it was understood that New Zealand is a great place for tourism. There's a lot of biotech research and farming. But at that time, I felt like if I wanted to go into, high tech, whether it's in physics or engineering, the U.S. is the place to be. So that kind of drove my decision to try and get to the U.S. I remember out of my entire school, I was the only one that applied to the U.S. And I think our grade had 500 students.
Oh wow!
So it was really rare, like even getting figuring out all the application materials, like what tests you have to take. It's not like you have a school counselor who just hands you all the information.
Yeah.
And at that time, internet is just like there is internet, but not that easy to find things on it. So yeah, it took a bit of effort to kind of pull everything together.
I was gonna say, because like the number that you just gave, one kid out of 500 applied. We're not even talking about one kid out of 500 that made it. We're talking about one kid out of 500 that even just applied to begin with. That is a crazy number. So you really, I don't know what was going on in your head, but like you had such a drive back then that no 16, 17-year-old like share. Well, not none of us, like none of the 16, 17, but like a lot of us would never have this drive at that age specifically to do stuff like that. So that's already pretty impressive. And then you were saying that, were there extra tests you had to take on top of all the ones that you took during high school already?
Right. I mean, it's the standard ones, SAT, TOEFL.
As in, like, did the 499 of the kids had to do those as well, or?
No.
Okay,
so the SAT is only if you apply for U.S. colleges.
Right,
and we also have our national exam
Okay.
for like New Zealand university entrance. So there's another set of tests.
So you still got to do that anyways,
yeah.
even if you're not going to
Yeah.
a New Zealand university.
That's right.
I mean, you got to cover your base of it. So it must be nerve-wracking, because I could imagine that if you're applying to a couple of different schools in the US, the time you get a response back is slightly further. I don't know if it's true or not, but like just because you're so far away that you know, by the time you get a response, it's a couple of days later than most people would. But I don't think it affects it that much. But
there is a good part about applying from New Zealand in that the school year actually ends in January.
Whoa, 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 whoa. Nobody told me about this. What's going on here?
Yeah. So the school year actually it starts in January and ends at January, I think. December or January. But yeah, there's a half year lag between the New Zealand school year and the US system. So yeah, actually after I graduated, I had like half a year off because I already, got my off letter, and yeah, there's a half a year to, I went back to Taiwan actually for that half a year.
Yeah, but nobody told me about this. Nobody told me that like they're delayed by half a year kind of thing. Top of my head, is there a reason why? I don't know if you know, but is there a reason why they're just different?
I'm not sure. Is it not that way in the UK? I would think that New Zealand would follow the
No, I think the UK is usually like they start in September and ends like well, I'm not going to speak for a country that I didn't like grow up in. But I'm pretty sure they're in the standard like September to I guess June and then every other month. Like, okay, the New Zealand fact, like I had no idea. It doesn't make any sense to me, but I guess that's how they do it. It might be beneficial. They might have some reasoning, but I'm definitely gonna dig into that on my own time at that point. But yeah, after that bit, so who was the lucky university to have you then? Which university was the lucky one?
Yeah, I ended up going to Northwestern in Illinois. It's about an hour north of Chicago. So Northwestern, they have a very strong material science program. Well, at that time, I wasn't really interested in material science, so I stuck with electrical engineering at that time.
Yeah, that's actually pretty cool. In terms of, I mean, just a lifestyle change. Let's talk about first. Like, talk about that first in terms of like. So you were still living with your parents in New Zealand, kind of thing, and then when you, I guess, decided to go to university in the States, it's basically you had to go through the whole dorm system again, or?
Yeah.
Okay.
Lived in dorms all 4 years.
Was that on the campus?
On campus, yep.
Was that close to Chicago? How close were you to Chicago? Did you have like time to like go to visit a city while you're at it, or was it just a completely secluded campus?
I probably went to Chicago like less than 10 times
in the
4 years that I was there.
Been.
It's just the transportation was really poor. If you didn't have a car, essentially you have to take the L. It's like a really, really old train system.
Oh, wow.
It takes 2 hours.
And to get to Chicago. Okay, yeah.
Yeah, so it was just way too much work to go downtown and back.
Yeah, but still, I think what would be interesting now is that like, in terms of when you say electrical engineering, for the people who haven't really taken the engineering, I guess, degree during university, what are the major points or major classes that you usually take in an engineering degree like that?
Right. So electrical engineering is one of those disciplines that is also extremely broad. So EE, has been around for, I would say, probably in the mid-19th century, people started doing electronics and analog, and then we went into digital once we have, semiconductor manufacturing with the digital computers. So it includes both like, analog electronics, like those that go into your, could be your sound card, your audio, amplifiers, and also digital computers. There's also the communication part, which is, how information is transmitted and information processing, basically. Digital signal processing, when you send information across wires, how do you receive it? How do you decode it? And there's also circuit design, also like power systems. Think about like large electrical grid power systems. So that's more on the more traditional side of electrical engineering. In the recent years, since maybe end of the 1990s and 2000s, most EEs, there's a lot of discipline work in semiconductors.
Right.
Obviously driving the computer revolution. And it also covers things like electromagnetics, like radio waves, lasers. So that's it's a huge.
Yeah, you're mentioning the whole broad topic because I mean, there's already like this kind of theme that obviously like we work in directly in software engineering, write a lot of software nowadays. When people say like electronics, nowadays most people assume electronics and computer are synonyms, but it's not true. Electronics is like every single piece of tech that you see out there, like you're mentioning all the circuit boards, but also all the circuit grids and all the other thermometers that you see like on the walls kind of thing. Like those are all like electric stuff. And then one thing that kind of clicked when you're saying like, oh yeah, figuring out how the signals or how the electricity goes through from one thing to another. Is that supposed to mimic like how the brain waves work, or are we still very far from that kind of comparison?
Well, definitely it's quite different, like how our the neurology of how the brain works. Nothing like the electrical systems that we have.
Okay, so that was just a really stupid thing for me to say there.
I mean, there are some parallels.
Yeah.
But yeah, I mean, you can think of the brain as a big computing system.
Yeah, exactly. All right, I was a little bit right then. During that time in university, did you actually do any kind of programming? Did you use any kind of software, or what did that environment look like?
Yeah. So in electrical engineering or engineering in general, there are components of programming, but mostly geared towards scientific computing and, for example, things like simulation.
Okay.
Less about like building software for people to use, but we're using computers to run calculations of, could be physical processes or to simulate something that we can use for designs or to study the behavior or physical systems that we can model. And so yeah, we did mainly programming in like MATLAB.
Yep.
Doing linear algebra. There's some programming at that time.
I mean, to the people who says MATLAB is not a programming language, I know you're out there. I know you're listening. We'll debate that on another day, but yeah.
Yeah, MATLAB was really great for scientific computing in general. They really built it for that purpose because it's based on linear algebra. And so that was kind of the workhorse in that sort of environment. But it's not great for performance. Certainly if you want to productionize any system, you probably don't want to write it in MATLAB.
That's the thing. I think just looking back, especially in university, when people say like, oh, I'm doing this language over another one, I'm doing C instead of Java or PHP or whatever. If you look back at it, it doesn't really matter. You just gotta, I think the important bit is hardening, understanding the concept and understanding how to approach a problem, how to like, whatever tool you're given, you gotta think before using the tool, right? Like, yeah, I could give you a hammer, but if you don't know how to use it, what's the point? So, and then when you mentioned the linear algebra bit, I'm guessing that's very tied with what you're doing nowadays in terms of like the direct impact of having done that before. You're still applying the same, logic today to solve some of your problems.
Linear algebra definitely is a foundational underpinning in machine learning because you're essentially dealing with large arrays of numbers and how you can model your data based on how these numbers represent the data. So yeah, linear algebra is a big piece of it. Machine learning also relies on a few other things like calculus, statistics. So it's like a combination of a few.
Dude, I just cringed when you said those words again. Like I've gone through all of them. I love it to death, but like in terms of me being good at it, that's two very different categories at this point. So that's really cool though. So that's like all the university life. Did you have time to do any like club life or anything? Because I know in the US, like they're big on it in terms of like joining clubs. So
yeah, that was really, I think a really awesome experience in U.S. colleges. That's club life is, apart from studies, that's what you're expected to do. Like everybody, finds something to do. So early years, I was involved in the Taiwanese American Students Club.
Yeah, nice.
And there I met a few friends and we started an a cappella group on campus.
Oh, wow, okay.
Yeah, so, doing singing. We had shows every year. I was actually also, had a lot of fun, playing rock music with few friends of mine. So yeah, we had a little band, nothing serious.
Well, what's the name?
Just a pastime.
What's the name of the band? That's all we want to know.
It was called Morphin.
Morphin?
Yeah.
That's not the worst name I've heard. Like, that's not too bad.
Yeah,
That's
could
really
be
cool.
worse.
I mean, yeah, that's what I was gonna say. But hey, I mean, anything happens during club life, during university and stuff. I'm slightly upset that we haven't had a duet while I sing so often, like next to you at my desk, and like you haven't joined in any of my stuff. So we might have to rethink about that.
Yeah.
And you're also really nice to not say that my singing is complete crap. So like,
I haven't heard you
that.
sing before, so.
Oh, maybe I just mumble most of the time. But yeah, that's great. I think like for most people is that like even when we're talking about like doing whatever and electrical engineering in university, or when I did computer science, like a lot of people just try to find different clubs that are not directly related to what you're studying at the end of the day. But do you feel that like it had a good impact on you anyways, on how you ended up maturing in your profession nowadays, or is it just a really good pastime you had back then?
You mean if the extracurricular activities helped in any way? Definitely, I would say definitely, because I mean academically, sure, you're learning a lot, but out here in the real world, you're dealing with people, right? You're dealing with, working together in groups, driving towards an idea that you all believe in. So I think the club activities really is an opportunity to learn and see how other people approach problems and work together. I mean, that's what it's all about. Yeah,
I 100% agree about that, because the way how it's set up is that like you don't have to be in engineering to join a music club or anything like that. It's people from all across the different programs, and you end up, and it's kind of like the real world. Like I don't only work with engineers, I work with all kind of different people, and like that usually I talk to all kind of people, and that's usually what the whole point of this is to begin with. But that's absolutely cool. And so how long was that? Did you do a 4-year degree then, or?
It was 4 years. Yeah.
And by towards the end of it, by year 3, 4, were you did you already have like a set mind of what you want to do after? Was it still like up in the air in terms of like, should I go to grad school? Should I go straight into the workforce? Like what was that looking like at that time?
Right. Since junior year, I had a pretty good idea that I wanted to go to graduate school. And the reason for that was I also had a very impactful advisor at that time. So I was in kind of a undergraduate research lab under Professor Taflov. He was one of the pioneers of computational electromagnetics.
Okay.
So this means that you can simulate how light interacts with the world, matter, using a computer. So I did 2 years of undergraduate research in his lab. And during that time, he was just so passionate about fundamental research and really drove home the idea that fundamental research is the way forward in terms of improving society and have a broader beneficial impact. So that kind of gave me the motivation to go on to graduate school continue to pursue electrical engineering.
Yeah, I think that's such a good position to be in to begin with, because I think a lot of people at that age specifically, it's like, do I want to go to grad school? Like the same question I was asking before, and it was for me exactly the same thing. Is that like, do I want to go to grad school? First of all, I don't think I'd qualify for grad school, so like that option was slightly a little bit different for me at that point. I mean, I've done the numbers. I don't know how that's gonna work. I jumped straight into the workforce, so like I'll do it. But that's actually really interesting. So what was the option there? Did you have the option to stay in Northwestern, or what did that look like at that time?
Yeah, so my advisor definitely encouraged me to stay at Northwestern. He's been at Northwestern many years, and he firmly believed that a lot of great work can be done from Northwestern. From my perspective, I really wanted to go see the broader landscape. So I didn't eventually decide to stay. Because I've been in the Midwest for 4 years, and the U.S. is such a huge I
was gonna say, you already made the jump from Taiwan to New Zealand and to the U.S. Like I don't see anything stopping you. So
Yeah, so I applied mostly to the West Coast at that point because, just a very strong tech scene in the West Coast. And yeah, that was my plan.
And let's say how many percent of those universities accepted?
Honestly, I don't even remember. I think I applied to 5 or 6 programs, like 3 or 4 in the West and a couple out in the East.
Right.
Yeah.
And did you feel like you did something that put you in a really good position to be a good candidate for those stuff? Because I do know some people are always trying to find ways to, get into, I guess, the same challenges you had back then.
Yeah. So I think it benefited me a lot that I started undergraduate research in sophomore year. So by the time I was a senior, I was able to publish a paper with another postdoc. So definitely, if you're thinking about doing, graduate school, having, paper publication
during your undergrad.
Yeah. I mean, it's a I would say for students who have thought about going to graduate school, a lot of them do, take part in undergraduate research fairly early on, and you can find a supportive advisor who, can put you under the mentorship of another, more senior member. Typically, you can get 1 or 2 papers out before you graduate, and that will go a long way for your application.
Yeah, for me, it's completely impressive. I can't recall remembering anybody during my university years that released paper during their undergrad. So I don't know if it's more common in the States than in Canada, but that is very impressive, and I wasn't expecting that. So, all right, that's pretty cool.
And the other part is having a strong, recommendation letters from several professors. So definitely, if you have classes that you feel strongly, motivated about, and that you made an impression on the professor, keep in touch with them, and by the time you need an application, that's when they can write you something meaningful.
That's completely true. I still have a recommendation letter from somebody 10 years ago that I'm more than happy to use nowadays. I don't know if it's true or not, but I very much trust the words on it. So, I mean, obviously I might have to ask them if it's still cool, but we'll figure that out. But yeah, so at the end of this whole thing is Stanford. Stanford were very lucky to have you. That's probably how it got.
Okay. So with Stanford, it's a very different environment from Northwestern, for sure. Even within Stanford, each department has its own culture.
Yeah.
And the fact that I went to electrical engineering, which was a very, let's just say, very competitive, department to get into, they are essentially they let you into the program, but whether you can graduate is kind of up to yourself. So, for example, I believe when I was there at Stanford, they admit about 200 master's students into the EE program.
That's a lot.
That's a lot.
That's a lot.
But if you want to get into the PhD program, you have to take a qualifier exam, the quals, and there they only pass half.
Okay.
They only pass 50% of them. So you're in this environment where you have to, first keep up with the academic work, but also prepare for a very grueling set of qualifying exams.
When when did those exams happen? After a year doing your master's, or when basically do you have to do those?
Right. So qualifiers you can take it your first year.
Okay.
Basically, everybody takes it their first year. If you fail, you can take it again the second year.
Right.
And if you fail twice, then you are out, basically.
Okay. Well, you still get your master's. It's just that you don't get qualified for
you get
the
your
PhD.
master's. And plenty of people do that. They get their master's, they go to Google, Facebook, and make a shit ton of money. That's totally great too. But yeah, for me, for most people, they get to Stanford their first year master's. During the first quarter, they take classes, but and then also prepare for qualifiers in January.
Okay. Well, there's no loss of not doing them, if you know what I mean. If you're gonna be there for a master's, you could, I guess you could qualify and decide not to do your PhD after, right?
Yep.
So
Absolutely.
I think from anybody in that position, if it were up to me, which it would never be, but
Yeah.
I definitely would have taken the calls anyways. I tried. If I got some bragging rights. If I didn't have it, I was like, I'll just graduate with my master's. It'll be
the consolation prize. You can just
exactly. That's my kind of world, But it's cool that the transition, it was like straight from undergrad electrical engineering straight to master's electrical engineering, which made sense because I do know some people who did a master's on a completely different topic than they did during undergrad. So that was quite cool. Needless to say, you qualified for the PhD.
Thank God. I
feel like a lot of stuff that you've done is like very calculated and like it really is justified, like a lot of stuff that you've done. And I think what were the benefits? Because I think you mentioned that it wasn't exactly the full length of a master's and a full length of a PhD. Is it considered like kind of like an expressway or?
There isn't really a combined program. Like you have to finish your master's, like all the courses for your master's, and as well as the PhD requirements. So there isn't like a fast track thing. How quickly you graduate, I think a lot of it depends on your advisor, what kind of projects you get to work on.
Yeah.
And that ultimately determines how quickly you can finish.
What's a range though? What's the fastest that you could get a PhD and what's the longest that people have been sucked into it?
I've seen people, like the quickest I've seen is 3.5, 4 years.
Okay, whoa. All right.
The upper bound, sky's the limit. Like people have done like 10-year PhDs.
Wait, so that's 3.5 years for what? For just the PhD or the PhD
Both.
and the master's?
Master's and PhD.
All right. Well, I mean, that is.
But it's very rare. It's very rare, and
I can imagine
the advisor has to be very kind of understanding and collaborative, and let you off with a simple conference paper or something like that.
Yeah. Well, it always has to have a reason at the end. So I mean, so far the story, I'm still confused in terms of like, how did this all become today? How did we all become building one of the sickest models I've seen around? Like, so I'm still trying to bridge a gap. But I think like one thing to wrap off of the Stanford bit was like, what was the lifestyle? As in like, Stanford is known worldwide. It's a name that people know. What was the impressions when you got there, I guess? Did it meet your expectation of Stanford that everybody around the world knows about, or,
For sure. It was a huge jump between when I was at Northwestern and Stanford. At Northwestern, the EE department wasn't, known to be the strongest. That there's very, very strong professors there too. But when I get to Stanford, you really felt that like, oh my gosh, everybody is like a genius.
Yeah.
Like you can spend so much time, learning the material, and somebody, just blows you out of the water, and everybody just knows so much in their own way. So yeah, it's definitely like a different league. And
Okay.
You just feel like you can learn so much from everybody.
But there's also some down-to-earth aspect to it still, in terms of like,
Yeah.
people were still around, I guess like around the same age anyways, we were still young at that time, and like
Yeah.
any young people will eventually do something stupid. So
I don't think I've ran into too many assholes.
okay, good. Shout out to all the Stanford people then. That's great. But that's really cool because, I mean, we don't always get to talk to Stanford grads and how they live their lifestyle over there. So I always appreciate this, especially I didn't grow up in the States and like either way. So that's my opportunity to do so. In between all this stage of undergrad and grad and PhD though, did you manage to fit in any kind of internship in between or any kind of like, I guess, part-time jobs or something like that?
At Northwestern, I did internships during the summer. Because most people, find something to do during the summer. There's no school program, or you can stay to take additional credits, but I didn't want to do that.
Yeah.
So yeah, at Northwestern, I went to Intel for both junior and senior year summers.
Geez, the Intel.
Yeah, I went to Oregon, Hillsboro, Oregon. They have, I think, 3 or 4 like huge fabrication facilities in Oregon.
Okay.
So very large facilities. Basically, the entire town is working
dumb.
for Intel. So yeah, I was there for two summers. They were very gracious and giving me a kind of an independent research project.
Okay.
So the team that I was with was building models to understand electrical interconnects. So interconnects are kind of wires that connects between your CPU and your memory. And the thought at the time is that the electrical interconnect will be a major bottleneck for computing because it takes a lot of power to send signals back and forth, and it will be very difficult to scale to faster speeds and lower power. So yeah, we're doing computer models on interconnects.
That ties directly into what you were doing. So that's actually like reasonable. Because sometimes internships will be like, oh, come in and do this, and you do absolutely nothing of what you're related to supposed to do. So Oregon in there, what did the campus look like? Because nowadays all the big tech companies, like a lot of perks, and it was like, free lunch. The campus has like 36 floors and all that. What did that look like at that headquarter?
Yeah.
Is that a headquarter?
It was not a headquarter,
all right.
but it's a huge building nevertheless. So Intel is a very traditional hardware company, and in contrast to software companies, hardware companies are let's just say it's less fun in the work environment sense. Everybody has cubicles. It's very office-like.
Okay. Yeah.
It's very generic in terms of its layout.
Okay.
But actually, I really appreciated the cubicles. I am firmly in the camp that open offices kills productivity.
Oh yeah.
So
when you have Perry sitting next to you as well.
that's an added productivity boost.
Oh, all right. Actually, this is the Geek MD. Is what hardware that they gave you, or did they give you any hardware? Did they even fly you out there? Like, these are all the questions that I have. Like,
they fly you out there. It was a standard. Well, at that time, if I think it was a standard like Dell laptop. At hardware companies, you don't like. It's rare to use a MacBook.
Yeah.
Because most of the scientific computing softwares runs off of Windows, unless you go into like supercomputing and that type of things. Then you start to use Linux and Unix.
Okay, that's really cool. Especially even from a younger perspective, is that like you just get into these like massive companies and like they might look a little bit more corporate or whatever, but you still get the chance to do so many different things that you don't get to do in school and all that. So I definitely do. Very jealous of never getting the chance to go into a Intel office or anything. But that's not the only thing that you did though. Did you do any other internships during undergrad, or is it just?
That was the only internship. At Stanford, it was all fully focused on research.
Justifiably.
Yeah. Oh, actually, my first year at Stanford, the first summer, because I haven't gotten into a research lab yet, I went back to Taiwan and went to work for a venture capital.
VC.
Yep. I just thought that I'd see what it's all about, see the work that they do. Try something different during
That's
that
one of the questions I've definitely asked myself. Like, what is it about VC? Like, we talk about this quite often in terms of like, I think one of the articles that we read about the other is like, how does a VC make money kind of thing? Like, why was your business there? Why were you there? What did they ask you to do there? And what did you find out?
Obviously, given my more technical background, I was there mainly to do industry research.
Okay.
So when they have potential entrepreneurs coming in for funding proposals, I would go and visit the factory, see and understand the technology that they are working on. So in Taiwan, a lot of the technology is around electronic manufacturing.
Yeah, Foxconn isn't that like a big thing over there?
Foxconn is Taiwan and China. So at that time, I was looking at a lot of cases doing, for example, touchscreen manufacturing.
Okay.
At that time, late 2000s, there's a huge wave of renewable energy. So solar was extremely big. So yeah, touchscreen and solar, and also various electronic components that are manufactured in Taiwan.
Were the numbers like eye-opening kind of thing? Did you see yourself like looking at crazy amount of money between transactions and everything, or?
Nothing too crazy.
Okay.
Nothing too crazy. The VC was mainly doing A round and B, series A and B. So yeah, nothing too big.
Okay, but even having that exposure and even working at startups nowadays today is like you could definitely see like you definitely learn so much from doing that. And did they have better perks than Intel, or was it still quite?
No, in Asia, the perks, don't even think about it.
Well, they don't exist in Asia, dude. Oh man, I worked for a startup briefly in Hong Kong, and like it was alright. Like it definitely wasn't like the perks that we get like most of the time. So. That's something that I always love to ask. Just different parts of the world, any parts of the world, whether Taiwan, Intel, Taiwan, US, New Zealand, all this kind of stuff. So, but there is a point where you graduated, right? There's a point where you spent so much time graduating and all that. And I think we're finally are we getting close to the bit where's the bit where we got all this data and all this stuff coming in? So what happened after you graduated from Stanford? Sorry.
Right. So my Stanford work was on optics and optoelectronics, which means a combination of electronics and optical components. And one of the natural industry to go into is LEDs, light-emitting diodes. So light-emitting diodes is a very efficient form of lighting produced within semiconductors. So I went to a startup called Sora. After I graduated, because they had this entirely new way of making LEDs. And their founder was a Nobel laureate, Professor Shuji Nakamura from UCSB, Santa Barbara. So I was super impressed by the technology and the people there, and really think that we could make a difference by building very efficient light bulbs.
That's really cool. And I guess the biggest example of LED, like, is it fair to say that some cars in front, you have like the old ones that are like yellowy, that's not LED, and the ones that has like the sick beams, those are LED, right?
Yep.
That's how I recognize stuff. I just take examples like that. So, did they require you to like start coding stuff there, or?
So how I kind of started more coding was we were bringing up our manufacturing capabilities, and each wafer where the LEDs are produced contains tens of thousands, hundreds of thousands of devices, so little LEDs, and we have to test each one of them on a device tester. So that generated a lot of data, so all sorts of characteristics of the LEDs. So when I started building a database to record all these measurements, and over time, as the data grew, there's more need to do analysis on, what makes a good LED. How do you tell when the LED works or don't work, and how do you improve the manufacturing process through data analysis?
Yeah. Can we backtrack real quickly? And when you said I built a database, like this is nobody just starts saying that without. So like this is the back then, nowadays, like if you build a database, like you just run something, you could run like a quick Mongo, Postgres, whatever you want, and like it spins up quite quickly. Was it like that back then? Well,
this wasn't that many years ago. This was 2012, 2013.
Right.
So we were using Microsoft SQL Server.
Mm-hmm. Yeah.
It was on-premise. Most hardware companies haven't started using the cloud back then. So yeah, we set up our own SQL Server instance and wrote our data loaders to take data in and out of the database.
Even that. And did you previously have the experience of, I guess, starting a database from scratch, or?
No, that was, I picked it up right there. I had no idea what was a database when I started.
Yeah, people take it for
not Excel
granted.
sheets.
Yeah, no. Well, Excel sheets are a database. No, I'm kidding. I do love it that some people just take databases for granted, kind of thing. Like, I mean, I had one database course during university, and I thought I knew everything about it, but boy, was I wrong. Like, and also I didn't even do that great in that class. So, but it's so good that even considering your background, doing all this crazy good study on all the electrical engineering, and then you're like, I gotta build a database. Like, did you find like documents, or like did you find those useful in terms of just like being able to?
Yeah, it's similar to, I guess, any software developments. You look for resources online.
Boom.
Microsoft's SQL Server documentation, I don't think it was that readable.
Okay,
so
fine.
you had to find a lot of just examples, here and there.
That's actually quite cool because I mean, like, I do know a lot of like electrical engineer, not a lot. I do know electrical engineers that ended up being software developers, or even like working with all kinds of actual writing software and that. And it's definitely more common than not. As in, like, a lot of people when they after they're in university, they're like, oh, I wish I went into comp sci, or I wish I did software engineering. Mm-hmm. It's not true. You could pick it up any other time after. You could, like your example, you're like, I had to build a database. Well, boom, there you go. Kevin's on the job and he absolutely gets it done. So what kind of use did you see it by the time it like picked up a bit of momentum and you had all this data? What kind of use did you see people use it for? Or
right, so the biggest advantage of building a very structured database to keep track of the manufacturing process is that in LED manufacturing line, or for that matter any semiconductor manufacturing, there are many steps.
Yeah.
So from start to finish, the process takes about 2 months. And there's literally like hundreds of process steps that you have to track. And so what the database gives us is a full traceability of what each LED went through. So when you look at the end results, you can correlate back to the process parameters, what made better LEDs, what made them brighter, what made them last longer. So really building that correlation and be able to experiment on the improvements was a huge deal.
Yeah, that must be crazy in terms of like performance-wise, even, because did that come up often where it's like, oh wait, or I guess software isn't performant enough, we can't run these numbers, or was that like?
Yeah, for sure. As we grow in the quantity and frequency of data, that eventually became quite a big deal. So over time, I had to learn how to optimize databases, figure out bottlenecks, indexes, and
sharding, something like that.
Well, at that time, we aren't that big yet to have to use sharding. But that would have been the natural, next step.
Yeah, to it. How long did you end up staying at Sora then? How long did you do that for?
I was here for 6 years.
Wow, for 6 years.
Yeah.
So
yeah,
you could definitely see how, I guess, the initial seed that you planted at that database and like kind of just grew up at the into. Pretty sure they still use it today.
I hope so.
Yeah, this guy Kevin's a legend over there. So, but yeah, after spending couple years there, where did you go on to after?
Right, so towards the end, the last 2 years at Sora, for some reason, I don't even know where, maybe just reading, about, where technology is going. I got really interested in machine learning just from, seeing how things evolve, what the potential of the technology could be. So I was like, yeah, this is a really cool field. I wonder if we can use it in manufacturing. And so at that time, Sora was starting to build a smart LED bulb that has, so basically it's a internet-connected bulb that has sensors that can sense occupancy. It has an audio microphone that can listen to sounds. It has an ambient light sensor. So I was like, yeah, maybe there's some place for some machine learning algorithms to kind of give some intelligence to this bulb. So just talking to the VP who was running that program, he said, go ahead and prototype some
Wow,
machine learning models, and
a green light,
we'll see how it goes. Yeah, so that's kind of where I started dabbling in machine learning, and taking online courses to figure out what the hell that I needed to learn. So a combination of both, some projects at work and just learning the fundamentals.
I'm really interested in when you said something like, oh, gotta whether do certification or whether get some outside resource to help you with that. Yeah. I think it's the gap that usually phases me a bit, is that like today I'm an engineer, I'm a software engineer, but the thing's like, how do I even start to work with data, or even like just having something convincing to be like, this is machine learning? So what was like some concrete like step that you had to do? Did you like, so given that you had loads of data and loads of things, like what was one thing, for example, that made that into machine learning, for example? Did you use a software that turned like TensorFlow and then turned that all into it? Or what was the point that really just made it into just looking at data and then turning into?
Yeah, so the core of the core objective of machine learning, or one core objective of machine learning, is to make accurate predictions. So your system is given some inputs, and you want it to produce accurate predictions of what the outcome would be. So that's a very simple way to think about it. It doesn't even need to require complicated frameworks. You can build very simple linear models with a few parameters. You can write it, with a single line of equation, and that can count as, making a prediction.
So like I could just run like any kind of, I guess, Node.js app and just like write some kind of prediction.
Yeah, you can write simple equations to give you the predictions you want. Obviously, you have to optimize the
accuracy,
your
equation,
your model to inform the right outcomes.
Yeah.
But the model itself and what it does is totally dependent on how you want to structure it.
Okay.
Obviously, now there's very powerful and advanced tools to use under different circumstances. But
yeah.
At that time, you always start with the simplest. I am a big believer of not overcomplicating things. Do the simplest thing that solves the problem.
Yeah.
So at that time, I was building mostly simple linear models. There are some tree-based models that people have found to be very generally applicable. So there's a few different model types that are often used.
Those models you were talking about, where do you grab them from? Where do you grab them from, and how do you use them? So like you have a very specific use case right now where you want to use it. So yeah, how basically the question is, how do you implement them?
Right. Nowadays, most applications don't require you to write the models yourself. It could be a simple package that you import to your program, and you simply feed it the inputs that you collected, and you tell it what outputs eventually comes out, and the program essentially maps that transformation for you.
Right.
So a very simple example people always use is like predicting housing prices.
Oh, that's a good one.
Right, so you give the model, the zip code, maybe, the time of the year, how many bedrooms are there in that house, and it will do a reasonably good job at estimating what the price of that house could be.
And like for the user, basically, it's a black box, right? You just put in some inputs and something comes out, and like it kind of answers the question that you had initially, where it's like, and that's really cool. So that's like for the people that are using models. Have you, or how long have you spent time like building the actual black box, so like the algorithms inside of it? Do you still do a lot of that today? Do you do less nowadays and use more of like stuff that exists already? Like what kind of balance we're talking about?
Yeah, so I don't think, I would say like 95 or more % of the work doesn't really involve coming up with new model algorithms. So let me maybe back up a little bit. In the field of machine learning, you could be more on the applied side, which is taking existing algorithms and frameworks and customizing it to your application or your needs. There's also the more research and academic routes where you do study algorithms, like how to come up with a different architecture. So that would be on more the academic research side. You would do more of that, mostly in academia, but there are big companies that invest a lot of time into fundamental research in machine learning, and you publish papers, go to conferences.
That literally sounds like R&D, basically. That's like
it is.
That's literally the
Correct.
the concept of that. So.
And so far, my path is very applied.
Okay.
Is simply, no real time in the product lifecycle to do that type of work.
Yeah, that's true.
So you basically go online, find something that suits your need, and try to make it work. You pre-process the data to make sure that your model is compatible with it, and also productionizing it such that it can be served, in its application.
Yeah, that's a good way to put it. Because just in context, what a lot of stuff you do nowadays is like text speech and voice stuff. Like that's really your area at the moment, and that's where like it's absolutely amazing to see how you're able to use that data set and like just turn it into something that is concrete, usable, and like imagine a store and you have like, oh, there's X amount of people going in, and then all these kind of like relatable stuff that people see. We end up getting this kind of information from like data that doesn't make any sense. So basically, it's just putting like some human understanding into a set of data that is all like digital and everything. So
yeah, that's a really good way to put it. In terms of the machine learning world, you're taking data, which is very abstract, right? It sits on a computer server. It's a bunch of numbers. How do you take that data and create something that can interface with humans?
Yeah, and actually this just reminds me, I think there's a company out in New York called Enigma, and their whole business model is basically that. I think what was interesting with them was that they would take some set of data of like how many fire accidents happen within a year in specific areas in New York, and then they would partners with like the fire department, to be able to predict and prevent all these kind of issues. So I think that's one of the relatable cases of it's very human, me and you, to know like, oh, we want to prevent all these like fire incidents, whatever. But this abstract data that comes in of like looking at how often it happens over there, there's a lot of people that does the hard work of turning that data into something useful at the end. And like I feel like you're definitely in that position of doing something similar with that. So. But yeah, I'm still trying to figure out how did you end up at Notable? How did we end up meeting at Notable at the end of over here? You were at Sora, you did loads of great stuff there, even just starting your own database, and even you were saying like putting in machine learning models and all that. And how did that momentum end up like making you even just explore more of the world?
Right. So after Sora, I was able to land a data science job at Change Healthcare. Change Healthcare is one of the largest healthcare IT company in the US. So there we are looking at using building machine learning services to help improve the healthcare IT system, the workflow, how information is handled between providers and payers.
Right. So at that point, you were a data scientist. Like, what were you at Sora then? Were you still a data analyst, data science? Were you still or you were just?
At Sora, the title is always scientist. It wasn't very specific because I was doing half physical science, studying semiconductors, and half doing data engineering and data science.
Okay. So and then by the time you got to Change, it was like. Boom.
It was purely data.
Data scientists, like get the data in there, get all of that. And when you were saying like, were you able to transfer the skills, as in like the way of tackling problems and the way of modelizing all of that? Was it quite similar to do at Change? Was it
Right. So at Change, certainly the fundamentals of machine learning, statistical learning, and Python programming was all directly applicable. what I found in large organizations and driving new solutions in enterprises, it's often comes down to a lot more human interactions and driving business plans and communicating what the model does and how another business unit can use the outputs of your model. So a lot of it comes down to forming that product framework and communicating that. So yeah, working in that environment also brings in another dimension of learning. That was really tough in the beginning because you have to navigate such a huge organization and lots of
inputs, I guess, from people kind of chiming in and trying to get every detail right and all that.
So I definitely appreciated the time just working on technical work.
Yeah.
Towards I think I was here about a year, and towards the end I was spending probably 80% of the time in meetings and calls.
Oh wow.
And yeah, it's a very different type of work.
Well, yeah. That also implies like the importance of the outcome of all the models. That really emphasizes on the fact that this could change. It could be a game changer for the company. It could be something that completely changes the direction of what somebody wants to build, or something that like is just disproving a theory that they previously had, which is never a case that you really want. So that's actually really cool. And then so in terms of like software wise, by that point at Change, what kind of software did you use as a data scientist?
Right. So we were building everything on AWS.
Okay.
We were heavily leveraging the AWS ecosystem. We were a Python shop. So all the programs are in Python. We don't have our own kind of end user products because we actually work with other business groups to improve their workflow. And so our outputs are usually a API that they can call. So they would send us, a request. We would output some sort of prediction for them, and they would use that in their products for the end user. So our infrastructure was mostly around EC2, so like virtual machines.
Yeah.
We have SageMaker, so these are like API endpoints that serves the models. And a fair bit of data engineering stack like Spark. And
I did a university project on Spark, dude. It's so funny. I mean, I could talk all about that, but I really do like all the software that you're talking about. Is that like those SageMaker, and all those environment, they're definitely like, would you say that nowadays they're like top of the league kind of thing? They're top of the game, basically. You got TensorFlow, you got SageMaker. Do you think those are like the creme de la creme at the moment?
There are certainly many other platforms, but I would say those are fairly common now. So SageMaker, like AWS has pushing really hard on SageMaker. They want that to be the one-stop shop for kind of machine learning services for them. So if you use AWS, that's the platform to use.
Yeah, I think so far everything is really great because we could really see that if you want to know how to use it, really know how to like models work, whatever, you have to put your own time into researching or getting the certification, or even just taking online courses to do that. Because I think for a lot of people that wants to get into it, like if we take me for example, I do have a background in tech, but it's like how much do I need more to know how to do what you do? What's the gap in terms of that? And I feel like that's always usually what is like the scary bit, the uncertain bit of, oh, why am I not doing it? Why am I not jumping into it? It's because like I could literally start doing it tomorrow, because when you're saying like, oh, just spin up a node program or whatever, just spin up like a tiny program, write a couple of lines, it'll work at the end. So
yeah, depends on the outcome that you want. But I would say, given a software engineering foundation, it is much easier to do this than if you do not have a software engineering foundation. So if you already know how to program, machine learning engineering isn't that too difficult for you.
That's the thing.
If you're focused on the applied side, there isn't really that much requirement on math, statistics and linear algebra or calculus. Certainly it helps, if you are strong in those areas. But really on the applied side, you could build already a lot of services without having
That's the thing. And it's also not to discourage anybody who doesn't even have a science or tech background to even try getting into it.
Yeah.
Same story as somebody who doesn't have a science tech background and getting into building some web page or whatever. Do you think that could be the same, in the near future? Like you would have these people that never had any programming experience and dive straight into machine learning, dive straight into data science and all that?
I certainly think it's very possible. The way that the industry is moving is that the tech giants are trying to reduce the barrier to machine learning.
Yeah.
Everything that is available on Google Cloud, on Microsoft Azure, AWS, they want everybody to use machine learning to make it as simple as possible. That said, if you don't have good intuition and foundational knowledge of machine learning, you could be wasting a lot of time. Sometimes you may not realize why your model works in training or when you built it, but when you put it out in the world, it performed much worse. So there's a lot of nuances that either takes more foundational knowledge or experience. That's where the
Yeah, I was gonna say, because it feels like a lot of stories so far is that, like, did you ever have like a mentor specifically for machine learning or like any kind of data science? Or was it always you that really pushed the barrier every time of yourself trying to? Not
a formal mentor. I certainly, when I wanted to get into the field, I called up all my friends in data science and asked them, what they recommend and what kind of paths they went through. So definitely, talk to people that are doing it.
And this is why we're here today. I'm pretty sure if anybody reaches out to you about this kind of topic, you're more than happy to answer those kind of questions. So I think that's really just the interesting bit. Just to finally wrap up, because there's so much good content so far. To wrap up in a nice way, I guess, nowadays at Notable, you're still doing a lot of the similar work, but different. I guess when we say like just a different industry at the end is like it's just different problems to solve.
Yeah.
But you're still applying some techniques that you've learned over the years of working the different models, and there's different software that are top of the league that we're talking about nowadays. I think a lot of people, for I guess like advice in general for somebody who wants to get into it, whether they have a tech or non-tech background, what's the good advice to get them motivated to go into that direction?
So first of all, obviously you should have some idea of where you want to go in 3 to 5 years, whether you want to be in the academic routes, like doing research, or you want to build something that directly impacts some consumers, some products. So that will take you on different paths. But say you want to get into the application side. I would say for machine learning, it's probably 60-70% programming and another 40% math and machine learning foundations. So if you don't have a programming background, definitely make sure you are comfortable doing programming first. Then some understanding of data analysis, like doing analysis of data that you're interested in. Could be sports, could be music, could be something that interests you, instead of just pulling some data set that you cannot relate to.
I agree with that, because you were saying like find a use case, find something that at the end of the output, it's something that you could look at, be like, oh, for X amount of times this happens. It's so satisfying whenever those kind of thing make sense. When you read it as a human and it makes sense to you, that's always the most satisfying bit. So
find something that's you think would be awesome to kind of bring to life, then just embark your journey from there. Everybody really takes a different path. I don't think there's a straight path to this. Well, that said, there are formal data science and machine learning programs now in
uni,
basically all universities. Even when I was starting this, that there isn't programs that formal programs. So that's the other path. You could enroll in a program to do it. A lot of people also take boot camps. So 3-month boot camp for data science. You build a project at the end. And depending on the program, some people do see pretty good success in landing jobs.
So what I'm making out of it is that like there's so many different ways of getting into it, and all you need is just that one step, that first step of
just gotta start. Yeah.
Yeah. Oh, I love that because you could apply that to anything, but specifically in our
exactly.
case, we're talking about machine learning and data science. So that's great though. Is there anywhere that people could follow you, or if ever they want to reach out to you?
Yeah, I'm very inactive on social media. I do use LinkedIn. So, definitely can find me on there.
Perfect. I'll definitely try to link that below somewhere. So if you guys have any good questions of machine learning, if you just want to have more insight and even mentorship off of it, Kevin's definitely your guide. No doubts about that. But anyways, Kevin, thank you so much for being on the show. And I'm going to catch you guys on the next one. So peace out, guys.